In this video, we will build our next player state, the duck state. This state will be engaged when the player enters a down move input while on the ground. This means we will also have to introduce a ground check into our player controller. Let's start by creating the duck state script in our player states folder. Before we move on, let's also write the init method for the move state. When the player enters the move state, we want them to start the idle animation, and we will also set their gravity scale back to the default value. We'll now begin writing the duck state. We want this class to inherit from player state like all of the other concrete states. We'll have to include the class in our custom namespace before it supplies the player state class in the autocomplete. Now we can ask Visual Studio to implement the constructor for us. Let's quickly move back to the player class so that we can instantiate this new state in our dictionary of player states. We also need to jump to the player state type enum definition so that we can add the duck state value to the enum. After we've added that value, we can use it to create the entry for the duck state in our dictionary. Now we'll return to the duck state and begin implementing its methods. For the init method, we can set the animation to the duck animation, and then once again set the gravity scale back to the default. Next, we'll introduce overrides of the managed update and fixed update methods, and then we'll begin work on the input methods. Let's add the set vertical input method and then work on handling the input. If the player is in the duck state and they stop entering a down input, then we want the player to transition back to the normal move state that we've already defined. This will be our first real state change. Remember, a state machine is a set of states with rules about how to move between the states. We have essentially just defined one of those rules. Now, let's handle the movement of the player when they are in the duck state using the fixed update method, because we will potentially be changing the player's velocity. We will copy the smooth damp code that we used in the move state because the logic will be very similar for the duck state. In this case, it's even simpler because the player is not able to run left or right while ducking, so we'll simply set the target value to 0. This is in case the player still has some velocity from before they entered the duck state. This way the smooth damp will smoothly bring them to a stop rather than freezing them in place as soon as they duck. This will actually introduce some complications we'll have to deal with later, because now it's possible for the player to slide off an edge while ducking. In that case, they will also need to transition back to the move state, even though they didn't release the down input. Finally, we also want to expand the move state so that the player is able to enter the duck state in the first place. In the update method, we will introduce an if statement that first checks to see if the player has entered a down input in the last frame. If they have, then we will transition them into the duck state. If there is no down input for this frame, then we'll update the player's animation and facing as we were doing before. This won't be necessary if we are moving them into the duck state. We can now test out our new state and the transitions we've set up. You should be able to run around and then press down to duck, and you should also slide to a stop when doing this. You should also be able to return to the move state by releasing the down input. That's all we need to do for the duck state for now. We're now going to introduce the ground trigger so that we can begin work on the player's jump ability. Let's start by writing an outline for how to deal with the jump input when in the move state. We will introduce the setJumpInput method into the state and then include an if statement to deal with the possibilities. If the jump input equals 1, then we want to have the player jump, but only if they are currently on the ground. For now, let's just leave a comment reminding us what needs to happen here. We are also going to check for when the jump input is released. We will use this condition to implement a variable jump height in the next video. For now, let's also just leave a comment here to remind us of our plan. Let's start by creating a new component for our player called TriggerInfo that will hold all of the information about its contact triggers. We will start with a ground trigger, but we will soon add other triggers for contacting a climbable surface or touching a wall. Let's attach this empty trigger info component to our player prefab before we forget. We will open up the prefab, attach this new component, and then move it right below the input info component because this component will also display useful debugging information. We will add references to our game settings and player to this component. In the awake method, we will assign these two references using the usual methods. We will find the player component using the GameObjectFind method, but it would also be possible to use the getComponentInParent method since this component is attached to the player. We will now add a series of public Collider2D references that will represent the different contact triggers the player will need to check. We will develop all of these triggers and their applications over the next few videos. We will also write a public reset triggers method that will allow us to clear all of the triggers each time we're about to check them. We'll start by setting the ground collider to null. We're now going to create some properties that define the positioning of our triggers relative to the player's position. This will allow us to run the collision detection more easily. We will start with the ground offset, and we will assign its value in the start method. This offset will place the trigger just below the player's feet. We are also going to keep a reference to a bounds object for each trigger that will represent the area where we are looking for a contact. We will also define this area in the start method. To calculate the size, we will expose the player's bounds object by adding a new property that returns the bounds object from their body collider. We will define our ground trigger bounds as a flat rectangle that is slightly smaller than the width of the player's bounds. We don't want the ground trigger to be the same size as the player exactly, because then it can be triggered when they stand right next to a wall. Now we want to introduce a property that will calculate the positioning of the bounds object whenever it is needed based on the player's position and the ground offset. The size of the bounds will always remain the same, so we only need to calculate the new position of the bounds each time. Let's introduce a reference to our trigger info component into the player state class, and we will also add two new variables that will help us define the triggers. We are going to use layer masks in order to make our checks more efficient by only looking for collisions with objects in certain layers. We will define one layer mask for the structure layer and another for the climbable layer, and we will retrieve these two layer masks in the constructor for the player state. Notice our trigger info component is now showing a field for each of our trigger colliders. We will also need to define these layers in the editor and then assign our tile maps to the correct layer so these masks take effect. If we navigate to the layer dropdown at the very top right of the editor and expand the dropdown, we'll see the option to add a layer. We will define 3 layers: structure, climbable, and overlay. Then we will go through each tile map and assign it the correct layer. Now we're finally in a position to check the ground trigger for our player. Let's add a public method called updateTriggers to the player state class, which will handle all of the trigger checks we eventually need to do. We will begin this method by calling the resetTriggers method we just defined. Now, let's define a method that will run the ground trigger check called updateGroundTriggers. We are going to use the Physics2D method called overlapBox. This function checks to see if the box we specify overlaps with any colliders in the scene, and then it returns the first collider it finds. The first argument to this function is the position where we want to place the center of the box. The second argument is the size of the box. These two arguments match up with the center and size properties on the ground bounds object we defined in the trigger info. The third argument is any rotation we want applied to the box, and the fourth argument is a layer mask for the collision check. We do not want our box rotated at all, and the ground is on the surface layer. Finally, we'll call this ground trigger method in the updateTriggers method above. Notice that if there is no collision, then our ground collider will still be null because we reset them at the top of updateTriggers. Now, let's move over to the move state so that we can call our new updateTriggers method in order to make use of the collision check information when controlling our player. At the beginning of the update method, we will call the update triggers method that we defined in the player state base class. The move state class has direct access to this method as a child instance of player state. Now our trigger info component should be populated with information about collisions from this frame. The first thing we'll do with this information is make sure that the player can only duck if they are actually standing on the ground. We'll add a second condition to the if statement that checks the ground collider. If the collider is null, then this statement will be false, but if there was a collider that was found by the box overlap function, then this condition will return true. Next, we will also check to make sure that the player is standing on the ground before allowing them to jump. In order to actually implement the jump, we're going to add another constant to our settings. We will define a jump speed that will be used to add vertical speed to the player in order to cause them to jump. We can then use this jump speed in the setVelocity method to instantly change the player's vertical speed while keeping their horizontal speed unchanged. Before testing the jump, there are a couple bugs we need to fix. But first, we're going to use gizmos to begin drawing our collision check boxes to make it easier to debug them. Let's move to the player script and introduce the Unity callback onDrawGizmos. In this function, we'll first check to make sure the application is running, then we'll use the gizmos class to set the draw color, then we can use the static drawCube method in the class to draw the collision bounds to the screen. In order to do this, we also need to introduce a reference to the trigger info component into our player script, and then be sure to set the reference in the awake method by using getComponent. Remember, this component is attached directly to the player game object. If we run the game now, we can see the first of our bugs displayed visually. I accidentally used the Y component of the player's size to set the width of the ground bounds. We actually want to use the X component for this. The other bug is that I used two different names for the solid layer of the map with the ground tiles. I called the layer and tile map structure, but then referenced it as surface. Let's first change these names to surface so that it matches with the code. This will fix the ground detection. Then we'll jump back to the trigger info component to ensure that the ground bounds uses the X component of the player's size instead of the Y value. Now, if we run the application, we should see that our ground collisions are being registered correctly, and our collision box has the correct width based on the player's size. Finally, we are now able to jump by entering the jump input when the player is standing on the ground. There is still one bug that we'll solve in a later video by introducing a physics material to our player. You might notice the player's movement is a little sluggish, but as of now you should have a working jump and duck action. In the next video, we will introduce the climb state so the player can begin interacting with ladders by making use of another collision check. And we will also finish our jump action by introducing a variable jump height feature.